Hey there, this is Team Wavy with our final presentation um, for senior project. I'm Seth.
I'm Pedro.
I'm Jesse.
I'm Emma.
So the goal of this project was to make an application similar to windy.com. Windy.com is a map with a variety of weather layers with an easily viewable timeline to see current and forecast data in different layers such as precipitation, wind speed and direction, temperature, and that sort of thing. And we set out to create an application had that was like Windy, and that, except in the case of showing historical data and climatological average data. It was geared towards layman instructors, with also use from researchers as a simple and easy way to view climatological trends as well as variation from year to year.
Okay, so now we're going to do a project walkthrough of what we're able to achieve. So this is our landing page. So we just kind of explain to the user like what's Wavy, what we're trying to achieve. But like the main goal of our application is definitely the map. So here we kind of have an interactive map that allows the user to query data and analyze data, historical data over time. So here we have our metrics such as average temperature, minimum temperature, maximum temperature, average precipitation, wind speed and direction, and cloud cover. So let's say here the user is on average temperature, he can go ahead, he can pick a date he wants to analyze the data. So here we have our data from 1980, so he can just go select a date. He can select a different month, let's say a different year. Say we want to go all the way to the 2000s, and we can see how the data is going to change. Then if you actually go to also different metrics such as maximum temperature, minimum temperature is going to change. Cloud cover, for example, you can see how the data is changing as we're connecting to the API and we're fetching different dates, passing different parameters. Also here we have this timeline rulers, pretty much allows the user to change dates faster, so we can analyze data over time. We also kind of created a feature, just to allow for data visualization, so the user can actually see how data is changing over time. So for example, let's say we pick a date in June 10th, starting from 1987. I can kind of use this timeline and kind of play. So you can see kind of the data changing over time. I can go ahead, I can pause, I can zoom, I can go into a specific region, I can query the data, see where the metrics, I can go ahead, maybe go into like wind speed. I can also go ahead and change. Then I can go ahead and I can play again. And see, you can see how the wind direction, for example, change. Also some of the metrics change as well. They're usually like kind of exemplifies what we're doing. So let's say we go back to Hurricane Ian that happened last year in September. They can really like show our functionality, how it works. So let's say Hurricane Ian was around September 27. So you can see here where the hurricane was starting, we can see how, all the wind was going down. And then you can kind of start to the 28th and you can see all the hurricane, was in direction of Naples. Unfortunately, Naples, well, was hit directed to the hurricane. So you can see how the wind speeds were going straight to the area. And then if you go out to the 29th, you can see how the hurricane was kind of going up. And then if you go to the 30th, you can also see kind of leaving Florida to the coast. This can also be seen through the average precipitation. So you can see how the rain in the last day was all the way up north. If you go here on the 28th, you can see how it was all over the county. The rain was over 2 inches in some cases. And if you go on the 27th, you can kind of see how the rain was down to the south. So in addition to this, we allow the user kind of analyze historical data by date, but we also want to allow him like how the data change over time. So we have this other map field called long-term average, which pretty much kind of joins together our data. So we have 42 years worth of data. We group them together and we make an average of them, so that allow the user to kind of understand how data is changing year over year. So for example, here, this metric is January 1st. So we're getting 42 years worth of data in January 1st. To help the user make and like analyze and kind of like make assumptions to identify, in the future, what is data gonna look like. So here you can kind of see, you can kind of like go through the dates, the averages. If you go to minimum temperature, you can kind of go back, you can play, do the same functionality. So you can go ahead and you can see data changing year over year. You can see how the metrics change, the colors. You can kind of zoom out. If you just want to like focus and analyze, let's say Gainesville, you can kind of see, okay, what are the different metrics in data for this long time average. And yeah, these are basically our map functionality. This is how it works. These are historical data. We're limited to Florida, but like maybe some next step, something that could be make this even more interactive would be to expand this map to all over the country. Also, we have functionality that allows the user here to identify which county he's currently on. Later, this functionality just add upon the map. It's just like a search functionality. Let's say a user, maybe a researcher, some more like someone who like kind of wants to like actually deep down the map and maybe like prefer to like visualize data into a table. He can just go ahead, pick a certain date, say 2006, and then he can pick like the region that he wants to analyze, and he can just go ahead and query. So he's gonna have all like we're gonna have even more metrics than we have in the map. So just can kind of help the user understand the region, what's going on, maybe query over time as well. So yeah, this is our project. So next steps, individual responsibilities. So Saf, if you can go ahead, please.
Thank you, Pedro. So I was in charge of gathering the data and organizing it into a database. So the data we're pulling from is the ERA 5 reanalysis from the European Center for Medium Forecast. So the ERA 5 reanalysis is 5th generation global climate weather for the past 8 decades. So we specifically connected to their Copernicus API by using Python scripts to query the data, and they have about over 130 different metrics that you can pull from. We only pulled about 10, the temperature, wind, etc. Then we used the Python pandas library to get the mean averages of the data. And so this is all stored in a PostgreSQL Supabase database, which is what is connected to by the backend to bring it to the front end to display on the map.
Okay, so my responsibilities was around developing the front end, so the map functionality, the front end. So the first step was to design the front end. So I went to Figma, just kind of did some initial designs. Then I also have to go on React.js and use a library called Leaflet to build the map and to build the front end components around it.
My individual responsibilities was using Go and SQL to create and enhance API endpoints and queries. For example, some of these consist of like max high temperature, min low temperature, which is selected by latitude and longitude and is grouped also by the timing is grouped by longitude and latitude as well.
Yeah, so my responsibility was helping create the backend endpoints. And I also made a really small feature, the search feature, which is designed to fetch and display the numerical climate data based on user specified date, latitude, and longitude. And on a form submission, it uses an API call to retrieve various climate data.
Okay. Yeah, let's mention this in below. We have the technology that we mainly use for this project. So React.js and Leaflet for the front end, Figma for the design, Go as mentioned for the backend and API design, is also Python for data gathering, and you also use Supabase for data. And thank you. This is our presentation. Yeah, let me stop recording.